So on this problem, basically what we got to do is we've got to graph these and then find out where it's continuous across the domain. So I'm going to use Desmos graphing calculator for this. And remember on this one, we have to plug in the domain first. So I'm going to say -4 is less than or equal to x is less than -2, and then you put a colon, and then you put x minus 2. Okay? Then you put comma for the next part. Then my domain is going to go from -2 -2 to 4. So we're going to say -2 less than, did I do equals to? Equals to x less than 4. They go all the way to 4 on that one. And this is not supposed to be here. That doesn't go there. And then they have 0.5 x squared. So I'm going to say 0.5 x squared. Oops. Okay. Well, that one's already a jump discontinuity, but that's okay. I'm going to finish because this will be, once I get this entered in, 25. Wait, what's the domain? 4 to 8. So I'm going to say 4 less than or equal to x less than 8. Are we including that? Yeah, it's inclusive. Less than or equal to 8. And then my function for that one was 25 minus 3x. So 25 minus 3x. So I got to zoom out a little bit, but this is my graph. Okay. So let's take a picture of that. And so basically we're just going to graph all of these and see how they fit in. So the first graph goes here. So this is not it because it's a jump discontinuity. Now what I mean by that when I say jump discontinuity is that if I graph this, in order to graph it, I got to jump from here to here. So that is not continuous. This is what we call a jump, because I got to jump from one line to the next, and it's discontinuity, which really means it's not continuous. Continuity. So when we get to the one that we want, I think B is the right answer, but we're going to have to plug all these in. So the domains are the same. I'm just going to, now we can graph the next one. So this is not it, okay, because they're not connected. Let's do B. So basically, just a couple of minor changes. X plus 6. So this one's going to be x plus 6. And then the next one is still 0.5 x squared, and then the 20 minus 3x. So over here, instead of 25, I'm going to put 20 minus 3x. Oh, shoot. It's not b either. X plus 6. X plus 6. Well, it's not b either because, again, we have this jump discontinuity. Maybe it's c. So let's take a snapshot of that. Again, as you look at this, it can't be this one because we have another jump discontinuity. And the question is, which one is continuous? So continuous means one line. Now it'll go all over the place, but it's one line. There's no gaps. You don't have to jump. In other words, you got to be able, when they say continuous, think in your head that you don't, if you were to graph it, you don't lift your pencil. That's how I remembered it. That's how my teachers taught it to me. You don't lift your pencil. So in order for me to graph this thing, if I came over here, I'd have to lift my pencil off the paper. Same thing here. I'd have to lift my pencil off the paper to do this one. Third time's a charm. So this one, we're just changing that to x plus 4. And everything else stays the same, I think. Look at that. Now this is continuous. The reason it's continuous is because every portion of the graph is defined. There are no gaps. There's no discontinuity, okay? Every portion of the graph is defined. In other words, I don't have to lift my pencil. So there's a couple places where stuff like this can be used. Continuous. Stock market is the most common place, right? I could do a piecewise function. Maybe the stock goes up and then it drops, then it goes up again, spikes, and then it drops down again. They use mathematics. Yeah, I mean, you can use a computer to model the data, and then that you can fit that right to the stock market, right? Like, so there's a stock that goes up, then it comes down, that goes up, then it comes down. Sometimes it looks like that. So, but the answer is C, because when I draw this thing, if I were to draw this on the graph, I can start here, follow my path, and never have to leave the paper. But here, if I graph this one, now I got to lift my pencil up and put it back down. And same for this one up here. If I graph this one, I got to stop, lift my pencil up, and then start over here. Then I got to stop, lift my pencil up, and then, so those are discontinuous. They have what we call a jump discontinuity, but a continuous one you can draw straight through without lifting your pencil.